Hi everyone, in today's lesson we're going to talk about sigma notation. A series is referred to the sum of the terms of a sequence. The symbol, called sigma, is used to indicate the sum. So you always have a few components of every sigma notation. You have the sigma, which represents the sum, and you have some x value here, usually x equals whatever, so x equals 1, 2, 3, whatever the number is, and this is usually your starting value, and it goes up to some value. So let's put an example as x equals 1 is what we start with, and 5 is where we will end with. And there's always some sequence, usually in explicit form, here. So let's look. Example number 1 says evaluate the sum, sigma, from k equals 2 to k equals 7 of this sequence. So it's very simple. What we're going to do is we're going to write out all of the terms starting with k equals 2. So we start with 2k plus 2. That's our sequence. And we're going to plug in when k is 2, because that's my starting value. K is 2. So 2 times 2 is 4. 4 plus 2 is 6. Then it says keep going up until we hit our end value, which is 7. So the next term would be 2 times 3 plus 2. So 2 times 3 is 6, plus 2 is 8. Then we keep going. 2 times 4 plus 2. So that's 8 plus 2 is 10. 2 times 5 plus 2. So that's 10 plus 2 is 12. 2 times 6 plus 2. That's 12. Plus 2 is 14. And then 2 times 7 plus 2 is 14. Plus 2 is 16. So it says write out the series in expanded form. This is expanded form here. Expanded form is just to write the series as a sum. So 6 plus 8 plus 10 plus 12 plus 14 plus 16. And when I ask you to evaluate it, I'm asking you to tell me what the sum is. So if you took a minute and typed in all this into your calculator, 6 plus 8 plus 10 plus 12 plus 14, you'll get an answer, and that answer is your sum. So take a minute, type it, and hit resume when you're ready for the answer. Okay, I got 66. So when you evaluate the sum, you get 66. Okay, let's look at example number 2. So example number 2 is the same concept, except there's a 5 in front. So that actually means I'm going to take my sum from here to here, and then I'm going to multiply that answer by 5. So this is kind of like in super big parentheses with a 5 in front. If I wanted to add 5 to the sum, I would do this. The sum from I is 2 to I is 4 of I squared, and then plus 5. So that would mean take the sum of all these terms and then add the 5. And this one here says take the sum and then multiply it by 5. So let's first write the series in expanded form. So we're going to start with the I equals 2 and go all the way up until we get I equals 4. So we have I squared, and we're going to plug in 2. So 2 squared is 4. Then we're going to plug in 3. 3 squared is 9. Then we're going to plug in 4. 4 squared is 16. And I'm going to stop at 4 because that's my ending value. So if I want to write this out in expanded form, the answer, the answer is 4 plus 9 plus 16 with a 5 in front, because that's when I'm multiplying it. And if I want to evaluate it, I just type all that into the calculator. So pause the video, type it in, and then hit resume when you're ready for the answer. Okay, your answer should be 145. Okay, now let's move on to the next page. Alright, so now I'm going to ask you questions like, use sigma notation to represent this series of numbers. So the steps on how to write a sigma notation is to first determine whether the series represents a geometric sequence or an arithmetic sequence. Then derive the formula for the nth term, or what we call the explicit formula. Okay? And then when you have your sigma notation, if you do it like this, your start value, which we'll call n is equal to 1, will always be my start value, and the end value will always be the number of terms that you have. So whichever we have, and in here will be my explicit formula. So this will be explicit, and this will be number of terms. So that's our setup. So let's look at this first example. How do I go from 4 to 10 to 16 to 22? It actually looks like we're adding 6. So my common difference here, D, is 6. So we did step 1. Step 2 now says find a formula for the nth term. So we have a sub n equals a sub 1 plus n minus 1 times d. A sub n equals a sub 1 is my first term, which happens to be 4. We're going to leave n alone, and my common difference, d, is 6. Now we can simplify, distribute the 6 in, and combine like terms. So a sub n is equal to 6n, and then 4 minus 6 is a negative 2. So this is my explicit formula. So when I'm making my sigma notation, remember I said we're always going to put n equals 1 on the bottom. We're going to put this explicit formula here. And on top, here is going to be the number of terms that I have. So in this case, it looks like I have 1, 2, 3, 4, 5, 6 terms. So this is my sum in sigma notation. Okay, let's try the next example. So number 4, it says use sigma notation to represent 4, negative 8, 16, negative 32 for the first 50 terms. So we have to first figure out if this sequence is geometric or arithmetic. And it looks like to go from 4 to negative 8, I'm multiplying by an r value of negative 2. So the first step is to write an explicit formula, and since this is a geometric sequence, my explicit formula is like this. And we're going to plug in my first term, which is 4, my r, which is negative 2, and we're going to leave it to the n minus 1 power. So if we want to write our sigma notation, we always have n equals 1. And the number of terms that we have, it says for the first 50 terms. So we'll put 50 up here. And the sequence, the explicit formula, goes here. So 4 times negative 2 to the n minus 1. And if you want to be all particular with parentheses, you really could put this whole thing in brackets, just like so. Okay, let's move on to question number 5. So it says, how is the series 1, negative 2, 4, and so on, written in sigma notation? So again, we first have to decide if it's arithmetic or geometric. So how am I going from 1 to negative 2 to 4? It looks like I'm multiplying by a negative 2. So it looks as though my common ratio is negative 2. So the first thing I want to do is write my explicit formula. So a sub n equals a sub 1 r to the n minus 1. A sub n equals 1 times negative 2 to the n minus 1, which reduces to negative 2 to the n minus 1. So again, if we're writing it in sigma notation, we're going to start with n equals 1 on the bottom. The explicit formula will go here. And then the last thing that we need on top is just the number of terms that we have. But that could be a little hard to see because you see how there's dot, dot, dot? That means there are some terms in between. So now you have two choices. You can count the amount of terms and keep following the pattern until you get 64, or you could solve for n using this formula. I'm going to try to solve for n. So we leave this as a sub n equals a sub 1 times r to the n minus 1. So I can use a sub n as my nth term, which we need to know is 64. I have my first term, which is 1. I have my common ratio, which is negative 2, and raising it to the n minus 1 power. So I have 64 equals negative 2 to the n minus 1. Now this next part's a little tricky, but you actually can make a common base with the negative 2. If you raise 64, or excuse me, negative 2, to the 6th power, you'll get 64. And then negative 2 to the n minus 1, and then you can cross off the common bases, and you get 6 equals n minus 1. Add 1 to both sides, and you get n is equal to 7. So that would be your number of terms here. So why don't you let that sink in a little bit, and try number 6 for homework, and then we'll move on from this tomorrow. Okay, have a great night.